Oui, c'est bon, elle me dit oui. C'est bon alors.
Ok. Attends, je vais juste couper River histoire que ça fasse pas gling. Et on est parti. All right.
Vous m'entendez pas là?
Okay, guys. So today I'm going to present you Deeployer. So Deeployer, what is it? It's a tool we've been working on lately at the direction technique to help doing deployments of applications in production. Why did we feel the need to build this tool? It's because deploying application is actually quite hard. And there are really a ton of different ways to deploy applications in production. For instance, quite often we are using Docker Compose on a virtual machine that is hosted maybe in AWS or in OVH or wherever we want actually. So Docker Compose is a simple solution to deploy. We can use a Kubernetes cluster when we have a large solution to deploy. We've been testing things like Amazon Fargate, which is basically an auto-scaling container solution provided by Amazon. There are also other solutions like Platform SH or Heroku that we actually have not tested yet. All those solutions are, almost based on containers, actually. That's what they all have in common. If we take a close look at Docker Compose, it's clearly the easiest solution to deploy an application in production. It's quite simple. You install the application on your virtual machine. You simply start with Docker Compose up. Everything starts, and it should be quite close to your development environment, which is rather cool. The problem is that it does not scale. If you need to deploy the application or two or more machines, it is becoming really quite difficult. If you have some specific needs, if you have many different environments, quite quickly you will start doing configuration via .env files, or you could even have several Docker Compose files, one for your development environment, one for your production environment, maybe one for the staging, because there are slightly different needs. For instance, you might want to have phpMyAdmin on one environment and not the other, or things like that. And using Docker Compose is really not that simple. When you start, you always think, okay, it's going to be easy, and then when you deploy in production, you realize, okay, so I have not HTTPS enabled in production, so I need to set up HTTPS. I'm going to do that with Traffic. How does it work? I want to set up, HTTPS with Let's Encrypt. I'm going to create this acme.json file. If you forget to put it, you're going to be banned after about 1 week. If you put it, you will forget to set up the correct rise, which must be chmod 600 on the acme.json file, otherwise it will fail. If you've been through that, you know what I'm talking about. It's just not that trivial. You can also forget to map the correct path to a volume, and for instance, lose your production database if you do that. You can mistakenly expose a database port and get hacked. It seems simple, it is not that simple. And of course, if you don't want to use Docker Compose, you can always use Kubernetes, which is a real complete solution for doing production environment. It's actually pretty cool if you want to do continuous deployment, because you can create one namespace per environment, and for each environment you can have a specific URL. So if you create a branch in your Git project, it's quite easy to get a complete environment just to test this branch. So Kubernetes is cool for that. And you can of course, scale quite easily because Kubernetes is done for scaling. The problem with Kubernetes is that it's absolutely insanely hard. Last year, I've been doing a presentation to you on Kubernetes. So for those who were there or who remember, in order to create a simple container and expose it, you need a deployment. You need a service, which is kind of which is an object that is only used to expose a port. You need an ingress to put the reverse proxy. If you want to have volumes, you need a persistent volume claim. It's insanely hard, really. And actually, it is so hard that on many projects, we started by setting up Kubernetes for the continuous deployment. And what happened during the development is that on the development environment, some people added, I don't know, a container, an environment variable somewhere, etc. And it was so hard to maintain that they completely forgot to add it in the Kubernetes setup. And well, the Kubernetes setup was simply not used because it was too hard to maintain, which is a shame. It's also really hard to configure. If you need to have different configuration depending on the namespace, you're going to start using Helm charts, which is adding another layer of complexity on top of Kubernetes. So it is really difficult. There are other solutions. For instance, there is Fargate by Amazon, which is a solution which is pretty cool to auto-scale containers. So basically, you upload a container in the Amazon registry, and you ask Fargate to instantiate it and maybe to dynamically add new containers as the load increase on your application. So it's pretty cool. The problem is that it does not handle really everything. It's only done for stateless containers. If you want to have a database container, you cannot use it. If you want to handle file storage, you cannot use it. You need to use S3. If you want a database, you need a hosted database. So you need actually a solution that is completely cloud ready. And it's actually quite hard to set up too. You need to master a lot of Amazon concepts, like what is a VPC, a virtual private VPS actually, VPN, virtual private network, security groups. There are a bunch of very specific Amazon concepts that you need to master. And of course, there are other solutions like platform as a service solutions like Heroku or Platform SH, which can be used to simply deploy PHP applications. With Heroku or Platform SH, basically you upload your PHP code and it will run on a special container that they build themselves. The problem is that you cannot build your own containers. For instance, it would be impossible for us to deploy Gutenberg on Heroku or Platform SH. So if we have specific containers, we need to deal with them in another way. And so basically, there are a lot of different targets. And we were looking for the holy grail of a tool that would allow us to describe an environment and deploy it easily on any of those targets. And so this is how we started working on Deeployer. And basically what we have been doing is we are looking for the ultimate configuration file. Something that would be actually simple and expressive enough to describe the configuration of an environment, but not that hard and actually quite easy to master by any developer. You should not need to be a DevOps with several years of experience to use this tool. And basically, Deeployer is targeted at our use cases, okay? Basically, we have a lot of applications. they are not that difficult. Usually they don't need special requirements. We are not Google, we are not Amazon, we are not Facebook. We are deploying applications that will run on 1, 2, or 3 servers. We want something that is easy to set up, with easy volumes to set up and easy HTTPS setup. If we have that, we can host maybe 90% of our applications quite easily. And so that was our target. And we wanted a configuration file, which we will call deployer.json, that could target several different environments. And today, we can deploy it in Kubernetes. Tonight, we will be able to deploy on Docker Compose. We still have a little bug, but it will be fixed. And in the future, we want this deployer.json to be able to target other environments, like maybe Fargate, maybe Heroku, or whatever might come in the future. And the result of this search is something that looks like this. Okay, so if you have a look at this, it's a simple JSON file that describes an environment. And well, let's do a quick zoom. First, here we have a quite cryptic line. It's a schema. It's optional, so don't worry about it. You don't need to put it here. But if you put this line, it's actually a JSON schema, and by putting this line in your IDE, so in PHP Storm or whatever IDE you are using, you will get autocomplete and schema validation, which is pretty cool actually, because, well, you can use your IDE to autocomplete, know what you can put, what keys are available, and it makes writing a JSON file much more enjoyable, of course, okay? Then you define your containers. Okay, so defining containers is quite easy. And if you have a close look at it, it looks pretty much like a Docker Compose file, right? Except it is JSON instead of YAML. There still are a lot of differences. But still, it's pretty classic. You define a container, you define the image of the container, the ports exposed by the container, the environment variables. If you're used to Docker Compose, you should feel pretty much at home. But there are some stuff that are a bit specific. Look here, I have a host key, and basically the host key is telling me, okay, expose php.myapp.localhost or .com or .whatever to the outside world. And as you can notice, there is no reverse proxy container like in Docker Compose. I don't need to set up traffic because Deeployer will do that for me. It's the role of Deeployer to handle traffic, not yours. You should not have to worry about, okay, I need to set up traffic in what version, whatever, etc. It's traffic that will handle this problem for you. And what is pretty cool is that we have built-in HTTPS support. You simply need to put HTTPS enabled in the host key here, and automatically traffic will be configured with Let's Encrypt certificate in HTTP 01 mode. And the only thing you need to put is to put a config key here with your email, and if a certificate is set to expire, you will be notified by email by Let's Encrypt directly. So basically, it's 2 keys, and HTTPS is enabled. If you've been through the hassle of setting up traffic with HTTPS support, each time I need to do it, I'm losing about 2 hours. It's really quicker to do it this way. And I'm speaking about a Docker Compose deployment, but if you're doing it in Kubernetes, you also have to set up certificates using a Site Manager, which is kind of hard. It's really easier to do it that way. If you need to mount volumes, well, it's pretty easy too. You simply need to declare a volume, and you specify a mount path. And one thing that you need to add is the disk space. Okay. In Docker Compose, you never care about how much space you're going to give to a volume. because, well, you don't care, it takes as much space as it needs on your hard drive. But here, do not forget that Deeployer can and will deploy in a Kubernetes cluster. And in a Kubernetes cluster, you need to create a private, a persistent volume claim. So basically, you need to set up a volume and ask some disk space for this volume. And you do this simply with this. If you are deploying using Deeployer in Docker Compose, the disk space key will simply be ignored. If you are deploying in Kubernetes, well, it will create a volume on a shared hard drive with this much space available. All right? Also, we have easy scaling, of course, because we have an integration with Kubernetes. So you simply can ask for 5 replicas of your application, and 5 containers will start in your Kubernetes cluster. And you do this with only one line, which is quite easier than in Kubernetes, believe me. One additional thing is that sometimes you can have private images. For instance, when we are developing in GitLab CI, we are doing, before deploying, we are doing a build step with Docker Compose build. So we are building a custom image, and the image is hosted in the registry provided by GitLab. So here, usually we have git.thecodingmachine.com /444/ the name of your project / the name of your image. And this image, of course, is not public. It is only accessible to people who have access to GitLab. And we need to give access to this image, and we do it in the config with registry credentials. In Docker Compose, you don't need to put the registry credentials because at least once you typed on your computer docker login git.thecodingmachine.com /444. But in Kubernetes, of course, we don't log in on the cluster to put those rights. So we set them up here, and it will automatically create in Kubernetes what we call a secret that contains those registry credentials. And so, well, that's pretty much it. There are additional keys, actually. I'm not describing the whole configuration file. You can define limits for your containers so that they don't hit too much memory or too much CPU. You can also add functions, but I'll talk about it a bit later. So how do you use this? Well, you write your deployer.json file, and then basically, if you have a simple solution and you don't need to scale, you install Deeployer and you simply type deployer-compose up. So it's like Docker Compose up, except you replace it with Deeployer, and it will read the Deeployer file instead of the Docker Compose file, and it will set up your environment. Okay, Deeployer Compose is not completely functional yet, but it will be tonight. So yeah, do not try this afternoon, right? If you want to deploy with Kubernetes, you use deployer-k8s, apply, you give the name of the namespace you want to create the deployer config file you want to deploy your environment to, and it will deploy the application automatically. Just before, you need to put a kubeconfig file environment variable, which contains your Kubernetes configuration file. The Kubernetes configuration files is what holds the credentials to Kubernetes. So you do this once, and then you use deployer k8s apply, and it will automatically apply the configuration to Kubernetes. I did not write it, but there are other commands like the export command that is actually generating Kubernetes configuration files that you can modify if you want. And there is the same thing for the deployer compose file. You can generate a Docker compose file. So, how is it installed? Installation is actually quite funny. You install it using actually aliases. Why? Well, because deployer is a Docker image. So basically, what you do is you declare an alias, which is deployer compose, which is actually running a container with the container with TheCodingMachine / deployer, and which is running the deployer compose command inside the container. Same thing for deployer KTS, and you add a last alias, which is deployer self-update, that will simply do a Docker compose pull to get the latest version of deployer. And with those three alias, everything is installed. There is one thing that I did not talk about yet. It's how you can configure the deployer file and how you can add kind of configuration variables. When you are using Docker Compose, if you want to add a specific configuration, you would use .env files, right? In Kubernetes, you would use config maps or end templates, or if it's really too difficult, you would be doing simply a full text replacement in the YAML files using sed and bash, which is what we are doing quite often at TheCodingMachine. And well, Deployer has a way better solution to do this. It is using JSONet. So if you've never heard about JSONet before, and that would be natural, JSONet is a functional programming language. And it's a functional programming language that looks like JSON and that is made to generate JSON. And actually, I think it has been developed by a team at Google. So here is a quick screenshot of the JSONet documentation. If you want to have a look at it, you can search it on Google. You can see you have a JSONet file, and basically it can have variables. Like here we're declaring a house_rum variable. Here we are declaring a pool variable, and those variables can be used into the JSON here and here, and it will automatically generate JSON from this file. Okay, so JSONet has variables, which is pretty cool. It also has functions and conditions. So here we have a slightly more difficult example where we are declaring a function named Mojito, which is taking 2 arguments. And basically here we have a condition. If large is true, then return 2, otherwise return 1 into the factor variable. We have some JSON, and at the end of the call, we are calling the Mojito function 3 times, and it will generate 3 keys in our JSON. So you get an idea of how it works. You can define functions, you can define variables, you can define conditions, and it looks like JSON, but it's definitely more powerful. And if you want to use JSONet with Deployer, well, what you can do is simply rename deployer.json into deployer.libsonet, which is the extension for partial JSONet files. And if you do this, you can start using JSONet into your configuration. What you need to know is that you need to use the std.extvar env function to put into the env variable all the environment variable accessible in your computer. And well, then, for instance, here I'm putting the CI commit ref slug environment variable into the namespace variable. I'm here saying that the URL, if the namespace is master, then it will be workadventure.re. Yes, I did not tell you, but this is work adventure is actually deployed with Deeployer. And so this is a deployer.libsonet file that is living at the core of work adventure. So if the namespace is master, I'm deploying on workadventure.re. Otherwise, I'm deploying on the test cluster of the coding machine. And I can use those variables directly into my containers. Here I'm specifying that the image tag is fetched from the namespace. Here I'm rewriting the URL based on the URL I developed earlier. I'm also feeding environment variables that in the Kubernetes environment directly from environment variables declared on my machine, actually in the CI. So you get an idea of how it works. It's actually, I think, quite readable and really powerful. Using JSONet, I could pretty easily decide to deploy, for instance, phpMyAdmin in a production environment and not in, in a staging environment and not in a production environment, simply by switching a variable. So this is pretty cool. What I need to show you now is how we can use this into the continuous integration in continuous deployment platforms like GitLab CI. And you remember that Deeployer is actually a Docker image. And it's pretty cool because GitLab CI is actually using Docker images to run builds. So using Deeployer in a Docker image is really trivial. All you need to do is add a job in your GitLab CI.yaml file. You put the image TheCodingMachine/Deeployer. You define your environment variables, the most important one being the one allowing us to deploy on the Kubernetes cluster. And then deployer-k8s apply. You give the name of the namespace, and actually we can choose the namespace based on the commit ref slug, which is actually the name of the branch. And by simply doing this, I can deploy on a Kubernetes cluster. Just a quick comparison. This is with Deeployer, and this is without Deeployer. Without Deeployer, I would need to get the configuration, write it into a file, create the namespace, make sure we delete everything before redeploying, apply everything, create the Docker registry to be able to fetch images. It's insanely hard. And this is only the GitLab CI part. Of course, I would need to write all the Kubernetes configuration files that are infinitely more lengthy than a simple deployer.libsonet file. And actually, there is also a GitHub action on Deeployer. At TheCodingMachine, we are using GitLab CI to deploy to do the CI. But for our open source projects, we are using GitHub. And so I also developed a GitHub action, which is basically a small piece of script that can run easily on GitHub, and you can use it like this. You can decide to use the TheCodingMachine/Deeployer. This is actually an action. Define your environment variable and the namespace here, and it will deploy automatically. A quick word about how it works internally. Internally, Deeployer is a Docker image, I already told you that, and it is containing a set of tools that will allow us to transform a deployer.libsonet file or a deployer.json file into Kubernetes files or Docker Compose files. And actually, there are two programs into this image. There is deployer-k8s and deployer compose, and they don't work exactly the same way. Deployer Kubernetes is actually a bash script. So a huge bash script, which is hard to read because it's bash. But basically what this script is doing is that it's taking deployer.libsonet and it is turning it into a deployer.json file using JSONet. JSONet is a program that is turning JSONet files into JSON files. And once I have the deployer.json file, I'm turning it into Kubernetes files using some JSONet and a tool called Tanka. And Tanka is basically a tool that it's a huge JSONet library that helps you turning JSON files into Kubernetes YAML files. And when Kubernetes files are generated, there is also kubectl that is installed into the image that is used to do the deployment. For the deployer compose part, it's quite different. Basically, the deployer compose file is a PHP script written with a Symfony console. And the script will turn deployer.libsonet into deployer.json using the JSONet program. But then once we have the JSON, we load it in PHP, and we manually turned it into a Docker compose.yaml file using array manipulations in PHP. Quite classic, actually. And then there is Docker Compose that is installed into the image too, and that is used to put the containers up, down, or whatever you would do with Docker Compose classical. Right? So there is a question, which is what's next, where we are, and where we want to go. And well, today I showed you that a deployer can be used to deploy containers into quite easily. And I find it more efficient than actually Kubernetes, of course, and possibly Docker Compose. I need to insist on one thing. It's done to handle production deployments. You cannot use it yet to deploy, you cannot use deployer yet in development environments. For instance, when you declare a volume, the volume will not be mapped to your disk. So you really need to create a container and deploy it. It's really a production tool. Tomorrow, what we could do is we could try to simplify a bit more the setup by supporting services. Here is a sample. Just imagine you could declare a services key instead of a containers key. And maybe I want a database, and I want to say the type of my database is MySQL. I've got a bunch of keys that are quite specific to MySQL. And this would turn, if we are using deployer compose, this would turn into a container, for instance, a MySQL container. But maybe if we are using another tool, like maybe a future deployer.aws that does not exist yet, this could maybe create a MySQL database into the cloud using RDS databases, for instance. And we could imagine a bunch of services. I said MySQL, but we could do it with Elasticsearch, with Redis. There are a lot of hosted solutions on Amazon, on Google, regarding this, or even with S3 buckets that are used to store files. We could make sure that deployer-AWS is creating S3 buckets, while deployer.compose could simply create a container that is emulating the bucket, for instance. Also, one thing that is clear is that we need your help if you want. The code is not very hard to understand, and if you want to use deployer and if you are facing issues, of course, we will be able to help. If you want to contribute to, that would be awesome. This is something that I'm not saying often enough, but all those tools, of course, are open source, and everyone, including you, is welcome to come and contribute by using bug fixes. If you want to add features like services here, well, it's actually not that hard to do. It's not rocket science. It's a lot of plumbing, but well, it can really help to get started deploying applications easily. And well, I hope we have something that, yeah, well, could help us deploy faster in the future. And yes, win some time and win some stability in our deployment environments too. Okay. Before we step into the questions, I just want to say one thing also. Right now, so this is very TheCodingMachine specific, we are working with Julien into trying to find a partner for our deployments and to handle the environments for us, production environments, but possibly also the test environments. And basically, this is something that is going on. Well, in the meantime, of course, we are going to continue doing as we are doing. I mean, either deploying into Kubernetes, in the Kubernetes cluster, or in specific Amazon virtual machines with Docker Compose. We are looking to delegate this part to a host that we could work with and have a good deal with. Okay. So, was it clear? And actually, do you have questions? Or did I lose every one of you?
I have a question.
Yes.
What's the catch? If there is one.
Sorry?
What's the catch?
What is the catch?
Yes.
It's never a catch. I don't. Well, I hope there is none. Well, it's first of all, it's really quite young, so you might run into troubles. For instance, with Docker with Deeployer Compose, it's not quite ready yet, but Kubernetes is quite stable.
Okay.
One thing is that you might, well, it is a subset of what is available on Kubernetes, and at some point you might want a Kubernetes feature that is not available in Deeployer, and that might be frustrating. And actually, what we did, because I have a solution for this, I'm going to show you. If you have a look at the configuration, yeah, and it still needs a bit of work, but what you could have is a need to put a very specific Kubernetes key into your containers. And actually, you can do this using, if you're doing libsonet, you can define in the configuration a function which is called car8s extension, and that will actually edit the generated Kubernetes files dynamically. So basically, the application here, the JSON above is going to generate Kubernetes files. Pardon? Okay. So this is going to generate configuration files, Kubernetes configuration file, and then you can patch them using this. But at this point, to be able to do that, of course, you need to understand Kubernetes. So we managed to hide 90% of the complexity. At some point, you might need to be forced to dive into Kubernetes, which is, of course, not that pleasant. But yes, I'm really trying to find the correct balance between how powerful deployer must be, and how simple it must stay. And the balance is not that easy. For instance, when we deployed Work Adventure, and this is a sample for Work Adventure, we had to put specific annotations for Prometheus to find the container, and we had to do this. Okay. Any other questions?